Welcome to 3 day 3. This is modeling, and we're looking at example 9, designing a box. Dixie Packaging Company is contracted to make boxes with a volume of approximately 484 inches cubed. Squares are to be cut out of the corners of a 20-inch by 25-inch piece of cardboard and the flaps folded up to make an open box. So the height of the box will be X. What size squares should be cut from the cardboard? Well, remember, this is volume. Excuse me. And we're going to let X equal the edge length of the cutout square and the height of the box. So now, in order to do this, much like the last time we did this problem, we have a length of 25 minus 2x, a width of 20 minus 2x, and we're restricted by the smallest side, okay, 20, because now this, when is this 0 and this is 0? When X is 10. Now, so that's the width of our box. So we're restricted by this, the smallest side, as we go through that. So now if we set this up, we have a volume, V equals X times quantity 25 minus 2X times quantity 20 minus 2X. And now our volume is 484 inches cubed. And I got that set up. Now, I'm going to set this in the calculator. This 484 is Y1. This is going to be in Y2. Okay, when I graph it, so it's going to look something like this in my calculator, and it goes through, and this is going to come all the way around, but I'm only concerned up to 20, or excuse me, up to 10. This is when that value is 0. That 2 times 10 is 20. But these points here are where it's exactly 484. The area, this part above 484 is where the volume is greater than 484. This area below, measurements below here, is when the area or the volume of the box is less than 484. So this is where the volume is more than 484. This is where it's less than it. Now, the squares with sides of 1.22 inches or 6.87. So this is 1.22 and this is 6.87 for my X. Should be cut from the corners for a volume of 484 inches cubed. So keep that in mind as we're going through. And I found those by just finding the intersection of this Y2, 484, and this being Y1. Okay. Now, an open top box is to be made by taking a piece of cardboard 20 by 40, cutting the squares of side length X centimeters from each corner and folding up the sides. Your turn. Set it up and get it done. And then turn it on afterwards. It's done in the same fashion. Now, write an equation in expanded form of the polynomial function v of x representing the volume of the box. Remember, we're using v of x for the volume, x being the value of our cutouts. Okay, so we're looking at this, and we have 20 minus 2x, because that's 20, and 40 minus 2x. Now, what's the domain? Well, the domain, and it's the realistic or relevant domain, largest cutout is limited by the smallest side. So the smallest side is 20, so my largest cutout could be 10. So x is between 0 and 10. If the volume of the box is to be 1,500 centimeters cubed, exactly, I can set these equal, and again, put it into your calculator, and this is 1,500. Okay, and this is your function as it comes through. Dimensions that give v equals 1,500 inches cubed are right here as I step through. Okay, now I was able to find 3.486 as my x, and I was able to find 3.486 here and subtract it from 20 and put 3.486 here and subtract it from 40 after I did that. I could also put 5 in there, and there'd been 5, 10, and 30. So 5, 10, and 30 work as well, and that's what I've got here. So these two sets of dimensions are the dimensions of my box. It'll be exactly 1,500 meters cubed. Sorry, it took me a while to find those units. Now, what dimension will give the maximum volume of the box? Well, dimension that will give you max volume, relative max. So we're going to look at that, and the max of it will be 1539, 1500 or 1539.6007 centimeters cubed when x is 4.2265. So the dimensions for maximum in centimeters cubed, and this is what we've got. Okay, and that's what our volume will be, and will be our dimensions when we do the max. So you got to keep your eye on the prize when you're thinking about these. We're still looking at that relative max, and we have that intersection. Everything above 1500 is more volume than 1500 centimeters cubed. Everything below is less volume. Okay, so keep that in mind as we're doing these problems. Now, we're going to go do some factoring. Find a polynomial with zeros at 2, -3, and -4. Well, this came from x minus 2, x plus 3, and x plus 4. So guess what? It's time to use your algebra. And I expect you to show this work. I expect you to show it this way. Okay, I've got this, and I got x squared plus x minus 6, because that's what these are, and I multiply the x plus 4 in there, and I get this expanded out. And now I simplify it and combine like terms, and I get this as my solution. So I expect you to be this good, or even better, because we're going to do some really funky stuff with square roots and things, and imaginary numbers coming up here in this part of the chapter. So keep in mind as you're going, FOIL is our friend. And we also can look at some other multiplication tricks. If you're having difficulty multiplying, please come see Mr. Bloom about it. Find a polynomial with zeros at 2, 1 minus the square root of 3, and 1 plus the square root of 3. Now this is going to be x minus 2, x minus the quantity 1 minus the square root of 3, and x minus the quantity 1 plus the square root of 3. And that's what we've got going here. So now we're off to the races to multiply these out. And there are some people that aren't very good with doing this stuff. We got to get better. So as we go through, I did this one first. Okay, that was the easy one as I went through first, multiplying them out. And one of the nice things about this is recognizing some tricks that's going on. But we'll talk about that live when we get going here. The next thing is I'm just going to multiply this through after I combine like terms here. And then I multiply this out, and then I'm going to combine like terms, and I'll finish. Okay, so finding a polynomial with zeros at 2, 1, negative the square root of 3, and 1 plus the square root of 3. And lastly, the last thing we got going is we're doing some calculator work. Now make sure you have gotten the catalog in your calculator and place diagnostics on. So you're going to go to your calculator, you're going to turn it on, and you're going to go second catalog, which is just above the 0. You'll arrow down to the D, diagnostic on, and as soon as you come across the diagnostic on, you will, and make sure it's diagnostic on versus diagnostic off, you'll hit enter, and that'll go to your main screen, and then you hit enter again, and then your calculator will return done. And at that point, it'll turn on your R and R squared terms after you do a regression. So after you put diagnostic on, you're going to use the cubic regression to fit a curve through the 4 points given in the table. So put in L1, these points, put in L2, these points. After you do that, you're going to run a cubic regression on L1 and 2 for a cubic regression. And when you do the cubic regression, this is what you should return. Your R squared should be 1. It's a perfect fit because it's 1. It's, some people say, well, that's very good. Well, you can't get any better than 1 when you talk about that. So it's a very, very good fit. Now, do the same thing with L3 and L4 in this table, except you're going to do a quartic regression. Okay, this should be an L3, this should be an L4. And we go off and get that quartic regression done. Make sure your numbers are the same. You should be a perfect fit again. And always try to pick a model with the lowest possible degree that has a reasonable good fit when you're doing these type of regressions. I mean, you can do all sorts of funky stuff, but keep it simple, okay? I guess there's a KISS rule that friends of mine would say, keep it simple, stupid. But just make sure you keep it simple. The simpler the model, the more likely it will be to work overall. Okay, well that's the notes for today, and remember the stuff that we've been doing this week, these are our assignments, and they've been up on the board. Make sure we get it done. When you get back from break, we will be taking a test on that Wednesday. We will have a review on Monday and Tuesday, and you'll have the test on Wednesday. If you're in class on Friday, you'll get a slip for the review. If not, you can pick it up on Schoology. Have yourself a super weekend and enjoy Thanksgiving.